You have clicked Launch on your Databricks workspace on AWS. But if you stop there, you are leaving security gaps, overspending, and building on shaky foundations. Today, I am walking you through the complete setup most tutorials skip, from IAM roles that actually work, to VPC configurations that prevent nasty surprises, all the way to setting up your first cluster the right way. Your AWS Databricks will fail unless you solve these 3 hidden flaws. Do not just grab an admin IAM role. The credentials you use to create this workspace must have a very specific AWS service quota increased. It is not a permission, it is a hard, silent limit that will stop your VPC creation dead, and the error message will not tell you why. Find your VPCs per region quota and increase it now. You will need the ability to create VPCs. Open your AWS console and search for service quotas. Find the limit for VPCs per region and request an increase to at least 5. This is non-negotiable. Your default quota is often only 5, and this hidden limit will cause a total, cryptic failure when our automation tries to build your network. Your AWS account needs permissions. If you cannot create IAM roles, you will be blocked. Go to IAM and check your user or role. You must have permissions for EC2, IAM, S3 and KMS at minimum. Missing these is the #1 reason for silent, infuriating deployment failure. Verify this now, it is your master key. You also need the Amazon resource names for 2 VPC endpoints, S3 and STAs. Without these, your compute clusters cannot launch or talk to critical services. You will face a cascade of confusing timeouts. Find these now in your VPC console. This single step will make or break your entire deployment. Trust me. They built your data lake on invisible, insecure infrastructure. Without this role, you are giving Databricks the master keys to your AWS kingdom. That's a massive, unnecessary risk. We create a highly scoped, cross-account role instead. It's the secure handshake, granting Databricks only the permissions it strictly needs to manage your infrastructure. This is our single most important security control. Do not just hand over administrator access. That ends today. This role is your security perimeter. We are attaching Amazon's 3 full access not as a gift, but as a temporary, strategic necessity. It allows the automated setup to complete. Immediately after this video, you will scope it down, locking it to your specific S3 buckets. This is how professionals start, secure by design. But which account ID? This is the moment we lock the door. The trust policy must specify Databricks' unique public account ID. You cannot use a placeholder. This single line in the JSO is your gate. Get it wrong, and the handshake fails, or worse, you grant access to an imposter. Let me show you the exact, correct value. This trust policy is the only key that fits this lock. We are not just entering an account ID, we are positively identifying the only external service allowed to assume this role. That value, which I'll show you next, is non-negotiable. Compromise here, and you've surrendered the keys to your entire AWS kingdom. They told you this was easy. They were dangerously wrong. Click that Create Workspace button, and you have already made your first critical error. The console you use defines your entire administrative reality. Using the workspace UI cripples your control. This is your one chance to establish true account-level governance. Get this wrong, and you are locking yourself out of the security and cost management you desperately need. Skip the default creation page entirely. Navigate directly to your AWS Control Tower or AWS Management Console. Here, you must set up your account using the AWS Account Console. This is the single source of truth for enterprise-grade control. The console you choose determines your destiny, automation, governance, and security for the next decade. Think of this IAM role as your master key. When you paste this ARN into the credential field, you are not just filling a form. You are permanently entrusting your entire data kingdom to this single, powerful identity. Get this handoff wrong, and your castle's security is compromised from the first brick. Precision here is non-negotiable. For the networking, click Advanced. This is your chance to lock everything down. You will define the private VPC and security groups that form your impenetrable data fortress. Do not accept the default network. This single choice determines whether your data moves invisibly behind your own walls or is exposed on a public highway. Your Databricks will fail. It is not the tool, but how you connect it. This is your secret weapon. The VPC is now your private data fortress. Choose a VPC ID you already trust, then lock it down with at least 2 private subnets for ironclad redundancy. This architecture ensures your workspace survives an entire AWS availability zone failure without skipping a beat. Here's how we lock your fortress down further. We will build dedicated, custom security groups, one for the control plane, another for your workers. These are your internal guards, enforcing strict, zero-trust rules so only authorized traffic flows between your Databricks components and your data sources. No leaks, no surprises. Now, picture private, dedicated tunnels straight to your cloud's core services. VPC endpoints for S3 and STS eliminate public internet detours. Your data traffic stays entirely within Amazon's private backbone, slashing data transfer costs while adding a massive, invisible layer of security. Public gateways are now a vulnerability you simply no longer have. Forget chasing shadows when a connection fails. VPC flow logs are your network's flight recorder. They capture every packet's journey through your private highway. When performance stutters or security alarms sound, you do not guess. You pull the immutable transcript and see the exact source, destination, and intent. You transform a complex black box into a crystal-clear audit trail. Your Databricks setup is crippled by a hidden AWS networking mistake. Your secure data center needs a dedicated, fortified vault. This S3 bucket isn't for general files, it's your DBFS root, the single source of truth for all workspace data. Its name must be globally unique, so prefix it with your account ID. This isn't storage, it's your foundation. Get this wrong, and your entire data architecture is compromised from day one. This bucket will hold your actual Databricks data, from managed Delta tables to MLO experiments. Lock it down with a KMS key from AWS, enforcing encryption at rest. No access is permitted unless it is audited and authorized through Databricks. This is the secure perimeter where your data lives and your models are born. Your production data deserves defense in depth. This isn't just about ticking a compliance box. We will create and assign a dedicated KMS key, giving you granular control over all encryption. I enforce this at the bucket level, so every single object, every table, every experiment artifact is automatically encrypted before a single byte hits disk. You hold the master key. Your bucket is now a locked vault, but the guard is still inside. That policy you just wrote. It means nothing unless you also lock the door behind you. Block all public access and force S3 to deny any request that does not bear your specific IAM role's signature. We are not just inviting guests, we are bricking over every other entrance to the building. Your Databricks on AWS will fail. Here's how to guarantee it will not. Stop. Right now, if you just click Create Cluster, you leave a massive security and cost door wide open. The default settings are for experiments, not production. You must configure 3 non-negotiable settings before you spin this up. I'll show you exactly what they are. Get this wrong, and you risk everything. Single node feels quick, but this machine will host your Spark driver and all executors. If it fails, everything crashes. For real work, multi-node is non-negotiable. The driver stays resilient while executors scale dynamically. Think of it as your command center with a dedicated, expandable workforce. This is your foundation's stability. Now, your instance family is a critical performance lever. Is your workload memory hungry? Go for the R series. Is it computationally intense? The M series is your choice. This isn't just picking a box, it is matching the engine to the terrain. Get this wrong, and you pay for wasted capacity. Get it right, and your jobs will hum with optimized efficiency. Stop focusing only on hardware selection. Your real enemy is idle time. A sleeping cluster is a leak in your budget. Auto-termination is your first line of defense, but it is blunt. The real power is in policies. They actively enforce your rules, automatically choosing cost-efficient configurations before a single dollar is wasted on a careless user's click. Hidden AWS cost gotchas doom Databricks before the first query runs. Is your cluster truly alive, or just a costly illusion? Do not trust the green checkmark. Let's execute a real PySpark job that pulls data from your secured S3 bucket. This smoke test is your only proof that networking, IAM roles, and cluster policy are correctly synced. Watch for errors or a successful data frame printout. Now, let's prove the outbound connection works. We will execute a final PySpark cell to write a small test file directly to your encrypted S3 bucket. Watch closely. This success is your ultimate guarantee. It confirms data lineage, access policies, and that your entire pipeline, from compute to storage, is fully operational. Perfect. This final, critical test proves your secure data perimeter is airtight. See how the query runs under your personal identity? IAM pass-through is live. Your data is now governed by fine-grained, human-centric policies, not just broad service roles. The setup is complete. Your workspace is locked down and production-ready. Open your CloudWatch logs. Search for the S3 VPC endpoint ID. The absence of traffic to public S3 IPs is your silent victory. This log is the definitive proof your data never leaves the AWS backbone. It's the final, irrefutable stamp that your private architecture is fully operational and secure. Avoid these 3 AWS networking mistakes that kill Databricks on launch. But your cloud bill. It is a silent killer. You need proactive defense, not monthly shock. Skip the generic thresholds. Instead, implement anomaly detection for Databricks workloads directly with AWS budgets, tying alerts to compute instance patterns. This gives you surgical control, letting you act before runaway costs become a disaster. Now, tags create visibility. But you need governance, real teeth. Enforce compliance by restricting tags to approved values with AWS Service Catalog tag options. This locks down your taxonomy, preventing creative chaos. Pair this with mandatory tags using AWS config rules. Non-compliant resources. They simply will not launch. You have moved from passive tracking to active, enforced control. Visibility, then control. Now, you enforce it. Instance profiles are your powerful financial levers. Assign specific, locked-down AWS roles to different workloads. Data ingestion jobs get minimal permissions. High-powered ML training gets its own. This granularity stops runaway spending dead. Your bill is now predictable, your governance ironclad. This is the pro-level discipline that defines a mature platform. Think of your logging like a ship's log. Without it, you are sailing blind into a storm. AWS CloudWatch is your permanent, unfailing record. It tracks every spark in the cluster, every byte moved. This isn't just data, it is your story. When costs spike or a job fails, you have the chapter and verse to know why and act instantly. The cross-account IAM role is the foundation. Get its trust policy right. Never use the default VPC, always configure private subnets and endpoints. Separate your DBFS root and data buckets with proper encryption KMS. Try creating a second workspace using a CloudFormation template for full infrastructure as code.